Okay, this video is an overview of the lesson in Edgenuity titled Solving Systems of Linear Equations, Substitution. When you do substitution, you have to isolate a variable, so that means get x or y by itself first, and then whatever you get, you substitute into the other equation. Okay, so for this first example here, just to get us warmed up with some substitution, if I told you that x equaled 2, and then I wanted you to then figure out what that meant for this y value here, well, what you would do is you take 2, you'd plug it in for that x, and you would say that y equals 3 times 2 plus 5. 3 times 2 is 6, plus 5 is 11. So the solution to this system is actually, you remember all solutions for systems of equations are ordered pairs. It's where the lines cross each other. So this solution would be the x-coordinate would be 2 and the y-coordinate would be 11. Okay, so now let's try one that's a little trickier. When you're going to isolate your variable, so to get one of the letters by themselves, it's best if you choose one that's positive and has no number in front. If it has, negative's not a big deal, but if there's a number in the front, you have an opportunity to run into fractions. So like for this one here, I'm going to choose to get this y by itself for no particular reason. You could choose that y too. So we have negative x plus y equals 1. I'm going to add x to both sides. So y equals positive x with a positive 1. Now, this time, it's not just a number. Here we just took 2 and plugged it in and solved. This time, it's a whole expression. So what I'm going to do is I'm going to take this whole expression, and this is what y is. It's x plus 1. That's what it equals. So I'm going to take that, and I'm going to plug it in for the y in the second equation. So we go 2x plus, now we're going to change y to what it equals, x plus 1 equals negative 2. So on this part, since there's no number in front being multiplied or anything, we can go ahead and just take those parentheses off and say 2x plus x plus 1 equals negative 2. Combine like terms. And then solve for x. So just subtract 1. Remember, if I'm ever going too fast, feel free to pause the video. And then the last thing we do is divide by 3. So x equals negative 1. Okay, so like I said just a minute ago, the solution to these systems are ordered pairs. So if you just find the x value, you're not done. You need to plug it in to get the y value. You can plug it into any of these three. I think it's easiest to choose the one that you isolated because y is already by itself and it makes it super easy to solve. So y equals, well, we know that x is negative 1. Negative 1 plus 1 is just 0. So the solution to this system, the x-coordinate is negative 1 and the y-coordinate is 0. That means these two lines are going to cross at the point negative 1, 0. So let's do one more. Again, you're going to want to choose the letter that's going to be the easiest to isolate. So this x is positive and it has no numbers in front, so I'm going to choose to get that x by itself. And the way I'm going to do that is I'm just going to add 4y to both sides. Okay, so now we know what x is. Even though it's not just a number, we can go ahead and take what we got for x. It's going to be 4y minus 1. And I'm going to plug that in to the x in the other equation. So I use this equation to isolate, so I have to plug what I got into the other equation. So don't forget that 2 is in the front, and then I'm going to substitute in 4y minus plus 2y equals 3. So on this one, we have a number outside the parentheses, so you're going to distribute it to both parts. So we have 8y minus 2 plus 2y equals 3. Combine our like terms, and then solve for y. So add 2. Divide by 10. So remember to simplify this fraction. 5/10 is 1/2. Okay, so we got our y-coordinate. We still got to get the x. Remember I said it's easiest if we go ahead and just use this one right here. So plug in a half for y, because that's what we got. Half of 4 is 2. 2 minus 1 is 1. So the solution to this system, the x-coordinate is 1 and the y-coordinate is 1/2. That's when those two lines will intersect. One thing that I want to talk about really quick, I don't know if I touched on it in the graphing, but it was in the edgenuity notes. So I know they talk about it in edgenuity, where if you have graphs like this, this is an example of one solution. They intersect at one spot. So it would be like our last answer, 1, 1/2 would be an example there. Sometimes, though, we have lines that are parallel and they never intersect. This would be an example of no solution. So when you're solving, the way this will look is you'll end up with something like you plug everything in and you end up with 2x minus 2x plus 5 equals 1. So then when I solve that, 2x minus 2x, well, that cancels. And then I'm left with 5 equals 1, which it does not equal 1. So that means there's no solution to that system, and those lines are actually parallel. Sometimes they'll try to trick you, and you'll get two equations that are the same. They lie perfectly on top of themselves. So when you're solving, this is infinite solutions. When you're solving using substitution, or when we get to combination, what this looks like in an answer is if we had, you start solving, and then it's 4y minus 4y plus 3 equals 3. So you're doing your solving, 4y minus 4y, oh, that cancels. Wait a second, 3 equals 3. So all the variables are gone. That's the difference here. On both of these, all the variables canceled out. The difference is this doesn't make sense, so that's why it's no solution. This one, yeah, 3 equals 3, so it's infinite solutions. And again, that's only when the variables cancel out. If they don't cancel out, you're going to end up with a solution like this, like we did in our 3 examples over here.